In the first part of this video, we did a quick overview of FLL Robot Design category and the judging process. Find the link below this video. In part 2, I would like to go into details about the referee sheets and especially about programming. First thing you should know is that the referee sheets are public. Everybody could go to the site of FLL and download them. Just go to the site, visit FLL events, judging and awards, and then download the rubrics. Here you can see a combined rubrics for all the three categories: core values, project, and robot design. Using the sheet is quite straightforward. There are three sections: mechanical design, programming, and strategy and innovation. For each section you have 3 rows and 5 columns. 2, 3, 4, 5. As the team enters, you should fairly mark their achievement in the given section, and this could be not demonstrated, beginning, developing, accomplished, exemplary. If you think that the team should receive an award for mechanical design, or for programming, or for strategy and innovation, mark them at the bottom right here. Take your time to get to know all the values in the different cells before the tournament. It would take you about 10 to 20 minutes. Also be sure to sync with the other judges in your team that you have the same understanding about these values. One of the most important things about this scoring sheet is to judge teams relatively, comparing them with each other and not on an absolute scale. I've been to competitions where most of the teams are really exemplary, which is great. Then you come to a situation where 2 or 3 teams are obviously better, but there isn't a second column for exemplary. So you should somehow adjust your judging. Leave the best 3 to 3 teams at the given competition as exemplary, and you can mark the others as accomplished. But that's again just a proposal. In the next videos there are a number of pictures I'll show you for different robots, but I would like to start from the programming section. Teams are allowed to use both NXT and EV3 software. These products are developed for young students that are just starting with programming. The first great challenge for us as judges is to evaluate the complexity of the program. Theoretically, it is completely possible to solve all the missions on every FLL field using only move blocks, like here. So move here with motor B and C, then lift something with motor A, then move again with motor B and C, then lift something again and move. But this is not a good program for a number of reasons. As students grow, and at the age of 14 to 16, when they are no longer allowed to participate in FLL, they should have basic understanding about programming autonomous robots. So consider the following scenario. Team A collects 400 points, and Team B again collects 400 points. Team A does it with one big program with just a sequence of blocks for moving. Sequence of blocks for moving. Team B has developed an autonomous robot with the use of sensors, variables, states, transitions, probably threads, and other even more reliable design patterns. So, which team is better? My personal understanding is that Team B has learned a lot more than Team A. They were more open-minded and would have greater potential to continue studying in the field of technical science. Let's now look at the first row of the scoring sheet. Exemplary, it states, should achieve purpose every time. And beginning is, would not achieve purpose and would be inconsistent. From my experience, programs that are relying only on blocks, like this one here, for moving, they depend on gaps, on the battery, on the initial starting position, and on many other parameters. So they would hardly achieve the purpose and would most of the time be very inconsistent. On the other hand, appropriate use of sensors, decision making, logical operations, variables, loops, switches, parallel using of different blocks, they could greatly increase the average score of the team. Next, we come to how well is the program organized and is it understandable. Where for beginning we have excessive code and difficult to understand, and for exemplary we have streamlined code and easy to understand for everybody. Many judges will now ask for comments, like this one here. I have personally over a decade of experience in software development. Comments, from my point of view, are the great enemy of every good software developer because they introduce redundancy in your code. This means that the next time you change the code, you should also change the comment. And if you forget to change the comment, which you certainly do, then looking at the code in 2 months from now arises the question, which one is correct, the code or the comment? Should I now change the code to reflect the comment, or should I change the comment to reflect the code? What I'm personally looking for in the programs is for them to be understandable. And if you cannot understand a simple program developed for the FLL competition in a matter of minutes, then you could consider this program as not understandable. Modules, or my blocks, could be used here. It's much easier to look at the program with the following structure: house and animals. Humans return to base. And it's much more understandable to see the sequence of the blocks instead of move, 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 and again move. There is a saying in the software development world: everybody could write a program that a computer can understand. The goal is to write a program that a human can understand. Looking at the last row, automation, navigation, you should have one thing in mind. Is it possible to develop a robot that the team could just start and without any intervention receive the highest score? So, no changing programs, no changing programs, no changing attachments, no strategic touching, and returning back to base. A robot that runs completely on its own. This should be the goal of every team. What I like to ask the teams here, for example, is how many missions do they have? How many missions? How many sensors do they use? When asking about the programming, try to understand the extent to which the coach was involved. I was once judging a team that had developed a state machine. checking the links below for more information about state machines. It was obvious that the coach had done all the programming. After a couple of questions, we found out that the students could not write even a simple program for following coins. The coach was completely honestly not aware that it should be the children doing the programming to the level they can. So to keep the competition fair, we didn't allow this team to participate in the robot game. Now I finish this video, and in the next parts continue with judging mechanical design and strategy and innovation. I have prepared some very interesting photos of robots, and I have gathered them throughout my experience. Find the links below to the other parts of the video.